I've got hold of some kind of rather special cards here, bicycle cards. But what's different about these is I have a red card here, which is red on both sides, okay? This is called a double-backed card. So it's red on both sides. I have a card which is blue, and it's blue on both sides, okay? And in the middle, I have a card which is blue on one side, and it's red on the other side, okay? So, red, red, blue, blue, and red and blue, one on each side. Okay, so let's put these together, and I'll just put them in this paper bag and give them a shuffle, reach in, and just pull out one card. Okay, now we can see I've pulled out a card which I'm looking at a blue back here. So the question is, what is the probability that the other side of the card is blue? Okay. What is the probability that the other side of the card is blue? So, what's the incorrect but obvious answer that many people say? The obvious but incorrect answer is reasoned as follows. You might think, well, the other side is either red or blue. And I know that when the problem was set up, there were 3 blue backs and 3 red backs distributed amongst the cards. And so red and blue are equally likely. So the probability that the other side is blue must be 1/2. Okay? So that's there is some faulty logic in that, which I'll explain in a moment. So this answer is incorrect. What's interesting about this incorrect answer is that this type of problem and similar problems have been conducted by experimental economists and psychologists who study probability judgments. And this answer appears an awful lot. Okay, so it's obviously a common problem with typical reasoning. So what's wrong with this answer? Well, the simplest way of saying it is that this answer ignores relevant information. Okay, nowhere in this answer do you see the statement, given that I've seen a blue back already. Okay, we just this answer, the other side is either red or blue are equally likely. This is just referring to unconditional probabilities. Okay, so if I randomly pick a card and I don't look at anything, what's the probability that the other side is blue? Well, 1/2. But I did look at the card, I pulled out and I saw that one of the sides was blue. Okay, so I've received some information. Once I have that information, I need to update my beliefs based on seeing that information. And actually, the answer is that the probability the other side is blue is equal to 2/3. Okay? This might not be immediately obvious, so I will explain the intuition for this next. I'll also point out here that this problem mathematically is identical to something called the Monty Hall paradox or the Monty Hall game. So if you're interested in this type of thing, you can find lots of resources online about the Monty Hall game, as well as the Bertram's Cards game. So let's discuss why the solution to the question, if I pull out a blue card from that bag, what's the probability that the other side is blue? And the answer was that the probability was 2/3. So why is this the case? Okay, so now you can prove this just by setting up a formal set of states and condition on the fact that you've seen a blue card and use Bayes' rule to say what's the probability of this being the double-backed card, the blue card, conditional on the fact that I already have seen one of the sides is blue. Okay? So we could do that formally, and I'd like you to maybe discuss that on the forum and see if we can formalize the problem, but I'll just give you the intuition. Essentially, there are 3 ways that I could see a blue card. I could pull out the blue card, I could see a blue face, or a blue back, apologies, when the other side is red. Okay, so that's one way which I could see a blue back. On this other card, I could have pulled it out this way, in which case the other side is blue. Okay, that's the second way I could see a blue card. I could see this side of the double-backed blue card. Or I could have pulled out this card this way. Okay, and now I'm seeing a blue back. Again, I know the other side is blue. So there are 3 different ways of seeing a blue card, 1, 2, and 3. And 2 of them occur when the other side of the card is blue as well. So 2 out of 3 times when I see a blue face, conditional on seeing that blue face, there is a probability of 2/3 that the other side is blue. Okay, so hopefully that's clear. But if the intuition's not clear, hopefully you could formalize it mathematically using Bayes' rule.